David Smith here with one more Flipped Classroom math video. 3 tips before we start. Remember, you can pause the video at any time to catch up with your notes. You can also turn on the caption down below and watch my words go by on your screen. Lastly, if you feel like you can do this, you can speed up the playback and get through the video a little bit faster. Today's lesson is designed to help you choose how to represent a probability situation in such a way that it's easy to calculate the probabilities that you may be asked to find. So check this out. What we're going to do is we're going to talk about choosing between Venn diagrams. That's one way. And the other way is sample space diagrams. And then we have 2 of those, two ways to represent sample space. So let's take a look. Sample space diagrams are best for combinations of 2 events, such as rolling 2 die, flipping 2 coins, things like that. This is best for sample space diagrams, and we'll go into those. Venn diagrams are better with 2 or more sets. And so these are things where you can have an intersection of 2 sets, such as people who are Asian, Caucasian, or both, if they're mixed race. So this situation is better for a Venn diagram. Okay, here's our first example. I have one of these situations where we've interviewed 38 people, 10 like coyotes, 23 like bobcats, and 8 like neither. So think for a minute about whether you're going to use a sample space diagram or use a Venn diagram to illustrate this particular situation. Okay, if you came up with Venn diagrams, you're right, because this is a situation where somebody could like coyotes but not bobcats, bobcats but not coyotes, or both, and then we also have a neither category. So this is really suitable for a Venn diagram. So now what I want you to do is pause the video and create that Venn diagram. This is good practice, so pause the video and do just that. Okay, here's my Venn diagram, all filled out. Here's the ABC addition stuff that helps me first figure out what C is, and then it's easy to get the intersection and then get the coyotes only. So there is our Venn diagram. Okay, now that we're here, let's practice calculating a few probabilities. So here they are, that they like coyotes only, that's the C. This one is that they like coyotes or bobcats, what's that probability? Remember, we're picking a random person in our situation. This one is the probability of the complement of liking bobcats, which means they don't like bobcats. And then finally, here's a little bit more notation. This is the intersection, so this means who likes coyotes and bobcats at the same time. So pause the video, do those calcs, and come right back. Let's see just how you did. So check this out. Coyotes only, 7 out of 38. That's the 7 out of the total. This 3, they do like coyotes, but they also like bobcats, so they don't count. The coyotes or bobcats is the most inclusive. As long as they like one of those, they're in there. If they like both, they're also in there. So that's 7 plus 3 plus 20 gives us 30 out of 38. Now, the people that don't like bobcats, which is the complement, that's what that little symbol means, of the people that do like bobcats, is 15 out of 38. Because that's this 7, they don't like bobcats, plus this 8 that likes neither. So that's 15 out of 38. Finally, this N stands for intersection. You could say it's and. So this is the people that like coyotes and bobcats. That's only 3 out of 38, because indeed, that's the 3 out of 38. Okay, I'm going to throw a couple more tricky ones at you, and then we'll move on to our next example. Notation here. This vertical bar stands for given that. So this is how many people, or what's the probability of picking a person that likes coyotes given that they like bobcats. So that means all the bobcat people, if you pick from all those people, what's the probability that they also like coyotes? Now this one's a little different. Now we're asking, what's the probability that they like coyotes if they don't like bobcats? So pause the video, figure those 2 out. Let's see how you did. So check this one out. The trick to remember is the given that part is the bottom of your fraction. And that makes sense because given that they like bobcats means that it's all of the bobcat likers, which is 23. So that's the bottom of the fraction. Now in those 23, only 3 like coyotes. So that's why it's 3 over 23. Now this one's just a little more tricky. It's what's the probability that they like coyotes if they don't like bobcats. So the bottom of the fraction is all of the people that don't like bobcats. That would be 7 and 8. So that's the bottom of the fraction, 15. And of those people, 7 like coyotes. Okay, here's another example. I want you to pause the video and think about what the best way to represent this sample space might be. We have 2 dice. One of them is what you would expect. It's got a regular dice layout. It's just 1, 2, 3, 4, 5, 6 on all the sides. But the second die is a little weird. It goes 3, 4, 7, 8, 9, 10. Okay? And then when we roll these 2 dice, what we record is what their sum is. So pause the video and decide which way you would like to represent this sample space. Okay. A grid or a table is going to be best for this sample space. So pause the video and build that grid. Okay, here's my grid. On the horizontal axis, I put the regular die, 1, 2, 3, 4, 5, 6. And on the vertical axis, I put the weird die, 3, 4, 7, 8, 9, 10. And then I just use my grid to add up what you would get if you rolled these 2 or these 2, etc. So I populated the inside of the grid with all those sums. So this is a quick and easy way to organize your work. So, of course, we're going to do some probability questions based on this grid. So your first one, what is the probability that the result is a square, like a square number, like a number that results from squaring something? So go ahead, pause the video and find that probability. Okay, let's see how you did. One of the reasons I like tables and grids is that if it's a weird situation like this, like result is a square, you can go onto your grid, you can circle all the results that work and then count them up. So here's a square, 9 is a square because that's 3 squared, and there's another 9, and then we have 16, which is 4 squared. So we don't have that many. In fact, we have 1, 2, 3, 4, 5, 6. So our probability is 6 out of 36, or a 1/6 chance that we get a square number. Next one. Now figure out the probability that the result is prime. All right, let's see how you did. This time I used my green pen and I circled all the prime numbers in my grid and counted them up, and there are 12. So our probability is 12 out of 36, or 1/3. Okay, let's take a look at the last example in this lesson. Here we go. We've got a family of 4 children. And the question is, what is the probability of having 1 boy and 3 girls in that family? So first off, I would like you to pause the video for a sec and decide whether you'd like to make a list, a Venn diagram, or a table/grid. So think real hard about that and come back. Okay, so if you thought about making a list, you're correct. You can't make a table because there's not just 2 things that we're checking. And a Venn diagram would be very messy and most likely not possible. So for this one, we just need a list of all the possible outcomes in a family of 4 kids. So what I'd like you to do now is pause the video and come up with that list of all the outcomes. And I'll give you a hint. The first item on that list could be girl, 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 girl. They could have 4 girls in that order. So you could write G, 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 G. So now pause the video. All right, here is my list. Now, these can be a little bit difficult to make because it's easy to miss one. In fact, I did the list. I knew what the result had to be. I knew how many combos there had to be. And I only counted to 15. And it took me a little while to figure out that I missed the girl, boy, boy, girl. So I added it on there, which gave me the right number of outcomes. So you might come up with your own way of doing it. What I did is I did my girl, 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 girl. That's an easy one. And then all the combos with 1 boy, I just moved the boy from being born last to being born second to last to be born second to be born first. So those are the 4 ways to get 1 boy. And it's the same thing here with the 4 ways to get 1 girl. I put the girl first, second, third, fourth, and then finally I have my 4 boys. So those are relatively easy. The 2 girls and 2 boys, that was a little bit more difficult to figure out, but I did get it. Sometimes this just takes a little bit of doing. Now, you might be asking a question. In fact, I'm going to ask that to you. I have 1 boy in each 4 of these. Why am I counting this 4 times? Isn't this just one outcome, the outcome of having 1 boy? Okay, the answer is that it's 4 separate outcomes because order matters. In this case, we had 3 girls born first, then a boy. This one is a completely different outcome. It's 2 girls born, then a boy, then a girl. So order is important. You have to count all these additional outcomes. So now I want you to calculate this probability. What's the probability of 1 boy and 3 girls? Notice how it didn't specify the order. So pause the video, do that calculation, and come right back. Okay, let's see how you did. 16 total. There's 4 here with 3 girls. So it's 4 out of 16, or 1/4.
Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also remember that you can watch the video again to remind yourself of what we did or deepen your understanding. If you enjoyed yourself, please click like or subscribe.